Linkage is exactly what it sounds like. If on a chromosome you have two genes, A and C, and little a and little c, what happens is those chromosomes carry those two genes together, so they are linked. That means that if you want to get new combinations, so for example, if you have two chromosomes, two pairs of homologous chromosomes here, so we've got 4 chromosomes in total there, each one carries one gene and therefore one allele, then it's very easy to get the new combinations. So this is the little c version over here, this is the big C version, and this is the big A version, this is the little a. So if I wanted to find out what the chances of me getting any of those combinations, I just have to do my meiosis. So I know that I could easily get big A coming together with big C in the gamete, I could get little a coming together with little c, but I could also get big A coming together with little c and little a coming together with big C because of the way that they are divided during meiosis. However, to get that kind of situation with here, these are linked. So my little c is linked to my little a and my big C is linked to my big A. So the only way that I can get new combinations is if crossing over occurs. And if that's a rare event, then it's not going to happen. So I'm going to end up with mainly big A and big C in my gametes and little a and little c in my gametes, and only very few of these new combinations here. So when that comes out in the phenotype, that could be the reason why I only have a few of those particular offspring that carry those, that have been made from those gametes, because they're on the same chromosome. Don't assume that linkage has happened in a question. They will usually tell you that linkage has happened, and then they ask you then to work out chi-squared with some results that they've given you. But remember, all that linkage means is that the genes are carried on the same chromosome, so to get new combinations of alleles, you have to have crossing over. Okay, Hardy-Weinberg is a way of figuring out in a population the incidence of a particular allele or a particular phenotype/genotype. And that's because the allele frequency is P plus Q equals 1. So you look for that in the question. If they say that the frequency of allele A is 0.8, then you know that the frequency of allele A, for example, which in this case would be P, would be simply 1 minus 0.8. You have to assume that there's only 2 alleles for that particular gene. Hardy-Weinberg will only work where there's 2 alleles for a particular gene. If the question is about codominant alleles, then it still works as long as there's only 2 versions for the codominance. So for example, if you had, in the case of the cows, a roan cow is effectively red and white combination, then that will work because there's only 2 alleles there. There's no extra alleles. In the case of the question, again, focus on the information that they're giving you. If they're telling you that the heterozygous condition is what you're looking for at frequency, then, so heterozygous frequency, we'll put that. And they say that the frequency of having the disease equals 0.2, and you know that the disease is recessive, then they've basically told you that Q squared equals 0.2. So then you could work out what Q is by doing the square root of 0.2. So you must work out all of the values. Once you've got what Q is, you know that P must be 1 minus the square root of 0.2, and then you can work out what P squared would be, and then you can also go back and find out if you've got P and Q, you can work out what the heterozygote would be, which is 2PQ. Don't try to jump to the answer straight away. Work out from what they've given you. If they're talking about the disease, if they're talking about the phenotype or the genotype, then it's this equation that you want. The only time you would use this equation is if they tell you that the frequency of an allele is this, or the instance there's 30 out of 50 that have 1 little a allele or something along those lines. Be careful reading the question. Read it 3 times before you start putting your numbers in for the Hardy-Weinberg.